The next theorem, this is called as the tangent to the circle theorem. Sometimes it is also referred to as the tangent theorem. So if you have a circle, say center at O, and you have a tangent that is hitting the circle. So let us have this. Now this tangent can actually proceed to arbitrary length. There is no restriction at all. So you can stretch this to whatever distance you want. Okay. For this question, I will stop till here. And this is the center. And you have a line that is actually meeting the tangent. So let me have this line as P, point of tangency as T. Okay. Now this distance is given as 2 units, and we are asked to find the radius. Find the radius of the circle. So this is one probable question, right? OT is the radius. Now we are going to be using this tangent circle theorem to get this value x. X has to be got. Now this is the statement. And a tangent meets the circle at T. For this scenario, the angle made by the radii and the tangent is always equal to 90 degrees. So using this theorem, we are going to solve this question. So this angle is 90 degree. Now for this question, we need to add one more parameter. I'm going to take PT to be as the root of 3, OP to be as 2 units. Now directly we can get the value of x. Now since angle T is 90 degree, we have triangle PTO, a right triangle. Right? So we can use Pythagoras theorem, which is PT squared plus OT squared is equal to OP squared. So PT squared is the root of 3 squared, OT squared is x squared, OP squared is 2 squared. So this is 4 negative. This is going to be root of 3 squared, which is nothing but 4 negative 3, which is 1. X squared is equal to 1, which means x is equal to 1. So we are dealing with a circle of radius 1 unit. Now this question can end here, but we can also add one more attribute or one more requirement for this question. So that can be, if they were to place in this letter S here, we have a sector created and they can ask us to find the area of the sector TOS, right? So that means they want this area. So imagine you are given a question like this. At first, if this angle is not known, this question can be very intimidating. But apparently because of this tangent to the circle theorem, we know this angle is 90 degree. And subsequently we have also got the value of x. Okay, so much so. Now let us actually get this angle. So let me take this angle as alpha. I need this angle to get the area of the sector. So if I were to take sine alpha is opposite side over hypotenuse. So this is going to be root of 3 divided by hypotenuse is 2, right? So let me work it out here. So sine alpha is root of 3 over 2. So alpha is equal to sine inverse of root of 3 over 2, which means 60 degrees. So this angle is got a 60 degrees. So therefore area, sector area is theta over 360 multiplied with pi r squared. My theta is 60 degrees, 360, pi r squared is 1 unit. 6 divides here 6 times, so pi over 6 square units is the area of sector TOS. Okay, so that's the solution for this question. So clearly you can see, all because we know this tangent theorem, we were able to answer this question. So let's move on.